So today is day 2 of talking about proportional length. Who remembers what we learned last time, Austin?
We learned about the triangular proportionality theorem.
Good. So you guys remember the triangle proportionality theorem? Yes. So if you have this triangle, and if PQ is parallel to RS, what do you know about TP over PR? Is equal to TQ over? Good. So you guys remember that? And remember we have a bunch of these. When you have these, when you have a triangle like this, where this line is parallel to the one of the side, we get all these proportions, right? Do you guys remember that? Okay. And what do we learn after this? A corollary came after this. Who remembers that? Who remembers that corollary? Nicole?
Three parallel lines intersect two transversals and they divide the transversals proportionally.
That's right. So there's a picture. And what do you know about then? You got 3 parallel lines, 2 transversals. What do you know about the ratio of RS over ST? That's equal to XY over Y. Do you remember how we drew this auxiliary line here, and then we used the triangle proportionality theorem twice, and we used the transitive to say, right, RS over ST is equal to XY over YZ. We're going to learn then the last theorem of this section. Yeah, question? Oh, you know what? Okay, hold on. Okay, Eric, you know what it is? Go ahead. Yes, very good. Some of you looked ahead. It's called triangle angle bisector theorem, and so it has a name. This theorem, it's nice, isn't it? And let me show you what it is. Here is what it says. If a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other 2 sides. It sounds sort of hard, but not really. If you look at the picture right here, do you see how you have a triangle and you have an angle bisector? Yes? See what happens when you have that. Go ahead, everybody write this down. And think about what this is saying. It sounds sort of hard. It's not really if you look at what's given and what you have to prove. Okay, go ahead. Everybody write this down. And as you write this down, see if you can figure out what it means. Okay. So Jonathan, what do you think this is saying here? If a ray bisects an angle, by the way, which ray are they talking about? That's right, DG. You'll see how DG is bisecting that angle D?
Yes.
Okay, and so it bisects. So what's the result? If that happens? Right. So here's DG bisecting the opposite side there, right? Then it says, then the opposite side, it divides the opposite side into segments proportional to the other 2 sides. What are the other 2 sides? FD and DE, right? So therefore, FG over GE is equal to what? FD over DE. That's all they're saying. Yes?
Like, how do you, does the order like matter? Like
The corners.
Yes. So yeah. So this corner FG over GE over FD over DE. Yeah, the order doesn't matter. Yeah, the DF is same as FD. Okay, any question? Does this make sense? Okay, so of course, we have to figure out why this is true, correct? So to do this, they're going to be drawing some auxiliary lines. So the first one they're going to draw is this DK, EK. Not right now. Let's take a look at this for now. How do you think they're going to draw this auxiliary line EK over here? Samantha? Parallel to DG, right? Because point outside of the line, there's exactly one line that's parallel to that. All right, then Jet. How do you? And then they have another one, DK. How do you think they're going to draw that one?
It's the same length as GE.
Not actually. Same length as what?
GE.
GE? Actually, not quite. They're yeah, in a way, sort of. But they're just gonna after you have this, right? You don't have anything, right? All they're going to do is extend this FD, draw a ray FD, and as it goes down, it's going to intersect a K. Is that okay?
Yes.
Now, the important part is why would they do this?
Oh.
Why would they even? One person see it? Naomi. Why would they even try to draw these? Of course, it's going to help us to prove, right? That's what these auxiliary lines do, right? So how is that going to be helpful for us? By drawing EK and then extending FD so that its array goes all the way, intersects at K. Is So you got a line that's parallel to DG, goes through E, and then you extend this, and then end up K. Some of you see it? Go ahead, everybody discuss with your group. Why are they even doing this? What's the point? Go ahead, everybody think about it. Okay, many of you actually were able to figure this out. Okay, let me give you a little hint here. So the reason why they drew E, line through E that's parallel to GD and extend this FD so that it ends at K is because, take a look at this big triangle. What do you guys know about this big triangle? In terms of GD and EK, they are? Do you guys know anything about, in a triangle, if a line is parallel to one of the sides? What do you know about?
Oh, triangle FKE is similar to FDG.
Okay, Samantha?
FD to DK equals FG to GE.
Exactly. Would you not agree? Look, let me call this A. No, hold on. Let me call this A. Let me call this B. Let me call this C and D. Guys, what do you know about A over B equals to, Samantha? C over D. Where do we get this from? Class? This is the triangle proportionality theorem. It's the very first theorem we studied. Hello? Right, Esther? Do you see this?
Wait, so we don't even.
Hey, hold on. Let me prove it to you.
So it's like
Right?
this,
Hold on.
right?
Hold on. You guys remember this? Well, I haven't shown it to you. Here. Do you guys remember this? You got a triangle. PQ is parallel to RS, right? What do you know about if this is A over B is equal to what? So, isn't this what we have here? A over B equals to C over D. Does that make sense? Okay. Right? So, let me rewrite this. What is GF? Yeah, okay. So, A over B equals to what's DF? C over, this is not D. This is something else. Let's call it E. Let's call this right here E. Is that okay? Right here.
Yeah.
Okay, so we got something similar. That's great, but except we have, instead of D, we have E, right? So wouldn't that be great if D is equal to E or something?
There's 2D.
Oh, because
There are two D's? No, small letter D.
congruent. And then you can see that D.
Okay, so everybody go ahead. Think about this. Wouldn't it be great if I could show that D and E? Oh, some of you see. Okay, go ahead. Everybody discuss. I'll wait. Go ahead. Think about it. Who can help us? What to say? All right. I think a lot of you know. Okay, so put your hands down. Okay, everybody. What do you know about angle 1 and 2? Right? Because DG was a bisector, right? Hold on. Okay, so Brianna, what can you tell me about angle 3?
It's congruent to angle 1.
Yeah, it's congruent to angle 1. Why, Brianna?
If two parallel lines are cut by transversal, then alternate interior angles.
Exactly. Then the alternate interior angles are congruent. So these two are congruent. Well, if these two are congruent by transitive, what do you know about angle 1, 2, 3? They're all congruent. All right, that's great. Do we know anything about angle 4?
Yes.
Oh, we do. Okay, how about who haven't I called? Amy?
If two parallel lines are cut by a transversal, then corresponding angles are congruent.
That's correct. So Iveta, what do you know about angle 2 and 4? So what do you know about angle 1, 2, 3, 4? They're all congruent by transitive, isn't that right? Because 2 was congruent to 1, right? And if 2 is congruent to 4, aren't they all congruent? Okay, so that's great. So we know that angle 3 and 4 are congruent. Amen? So what?
So,
Triangle DEK is an isosceles triangle, right?
yes, sir.
Is that nice?
Yes.
Why? Because I haven't called John. Because what? So what? So what if we have an isosceles triangle?
Then D was E.
Yeah. Don't we know that D and E are equal to each other? Yeah. So could we replace E with what? Or could we replace D with E then?
Yes.
Right? Because D is equal to E, then isn't that what we get?
You said D equals D.
Oh, sorry. I always do that. D equals to E, right? There you go. Yes? So we know that dk, you see this right here?
Yes.
I haven't even told you what. You see dk equals de. That's same as saying what? D is equal to? Right? So therefore, we get what we want, right? All we have to do is replace d with d because they have the same value. Because you have an isosceles triangle. Does that make sense?
Yeah.
So this triangle angle bisector theorem really comes, this is because of really the triangle proportionality theorem, right? That's where it comes from, really, doesn't it? Does that make sense? Okay, do you see how they use these auxiliary lines cleverly, like using them cleverly so that it comes out this way? Easy?
Yeah.
All right, let's do some examples. Okay, everyone try example 1. You got a triangle ABC, and can you tell me? Yeah, go ahead. CD over DA equals to what? What can you tell me about CD over DA? And oh, this one? Yeah, I didn't have to. Let me make this one better too. Yeah, these two are parallel. No, it's not. So I'm just saying AB is parallel to ED. That's all. Okay. And then if CD is 3 and DA is 6 and ED is 3.5, can you tell me what AB is? And lastly, can you tell me what DA is if CB is 12, EB is 8, CD is 6? Go ahead, everybody try. You can help each other too. Okay, I'll wait. How many of you wrote down B for 7 for B? That's how you get it wrong. Okay. So when you put down 7, that's not right. Okay, if you put 7, it's wrong for B. Okay, figure out why. Alright, first of all, everyone should have gotten what A is. CD over DA is equal to what, class?
C over E.
Because of?
The property of
No, triangle. Okay, hold on. What's the answer?
Corresponding sides of similar triangles are in proportion.
No, it's not. This one? This is not. How is this? Hey, how is yeah, how is C to? I mean, wait, CD to DA? DA is not a part of a similar triangle. Hold on. What is this from? This is from the triangle proportionality theorem. Remember? You got ED parallel to BA, right? Be careful. Yes. Okay. Now, but for B though, a lot of you put down 7 initially. That's not correct because can I do this? So let me write down what I have. CD is 3, DA is 6, right? And then they give us ED, which is 3.5, and then let's call it X, AB. Can you do this? 3 over 6 equals to 3.5 over X. Can I do this? Why not? You're right. This is how you got 7. This is not how you do it. How come it's not right? Okay, Naomi? Hold on. Naomi? Yeah, why can we not do 3 over 6 equals to 3.5 over X? Because you get 7 as the X, which is not correct.
6 is hard. JK
What should we do, Naomi? Okay, guys, listen. Pay attention. Naomi, what should we do? Instead of 3 over 6 equals to 3.5, it should be 3 over 9. Okay, it should be 3 over 9, right? This is not correct. 3 over 9 equals to 3.5 over X. Why do we need 3 over 9, not 3 over 6? Why can't we just do 3 over 6? Isn't that the triangle inequality? I mean, triangle proportionality theorem? No, it's not. Why not? Nicholas?
Because it's not the triangle proportionality theorem.
Right?
Because it's not the two sides.
Yeah, this is not two sides, right? ED and AB, are they the two sides? Let's go back to the theorem. They said what? It divides the two sides proportionally, right? Those sides proportionally. These are not the sides, right, that is dividing. It's just like we said right here. It divides CE over BE, right? Not these. So why are we using 3 over 9 equals 3.5 over X? We have to use, here, what are we using? Yeah, we're using, not scale factor, we're using the definition of similar triangle, second part. What do you know about the corresponding sides of similar triangle?
They are proportional.
So we're looking at this triangle right here and we're looking at this big triangle.
That's so smart.
Does that make sense? So if you're going to go with 3, listen, if you're going to compare 3 to, you got to compare this whole side. What is this whole length? 9. So you got to go 3 to 9 as to what? 3.5 to x. If you're going to compare 3.5 and x. Does that make sense? How many people got this? Raise your hand.
Me.
All right, so what does it come out? Young, what's the answer? Correct. It comes out to be 10.5. Guys, do you see why I put a star on this?
Yes.
If you just blindly use 3 over 6 or equals to 3.5 over x, yeah, you're not going to get it right. You got to know what you're really doing. Yes? All right, let's look at C. C, they say C. Let me erase some of these. Okay, so give me a sec. Okay. Andrew? So to do C, we know that CB right here, this whole thing is 12. EB is 8. And CD is 6. And DA is 0, Y or something. Okay, what are we going to do for C, Andrew?
What?
How are we going to find DA?
12 and 8.
Yeah, because we don't need this whole thing, CB, do we? We need EC. What is EC then? 4, right? 12 minus 8. And what are we going to use to do part C? Which, yes?
No, we use a theorem.
Which one?
I think it's a triangle proportionality.
Yeah, the one that we just talked about, triangle proportionality theorem. So guess what? Dylan, which proportion are we going to use here? Right, so tell me what to write. 4 over 8 is equal to? Exactly, 6 over? Y. And Brandon, did you get the answer?
Yeah, I got 12.
What'd you get? 12 is correct. Everybody agree? Isn't this 12?
Yes.
What's 4 over 8?
One
Half. What's 6 over 12?
One
Half. Half equals half.
No, I got it
Oh,
wrong.
I did it.
Uh-oh. You need to be able to solve these simple equations. Any question? Is this easy or hard? Okay. May I go to the next example? Question? Okay, hold on. We got a question. Guys, listen. Yes.
Wait, never mind, I got it.
You sure? Any question? All right. Let's go to example 2 then. Okay. So take a look at this example. Do you guys remember doing something like this before?
Yeah.
We talked about which bunch of proportions that are true. Now, but some of these may be false. So I want you to verify which one of these are true and which one of these proportions are false. Go ahead, everybody think about this. I'll wait. Okay? Everybody try it. Yeah, write it down. Do it. Okay, go ahead, everybody try. So take a look at A. This whole thing, this side J to B, is that equal to K to D? Is this true? Yeah, this is true. Right? Does that make sense? You could actually work this out algebraically using all the theorems and stuff we learned. Okay, what about B? C to A is the same as K to J. Yeah, this is true. Right? Okay. What about A to C as 2? Oh, that's actually the theorem, right? Isn't that okay? A to C as B to D. Whoa. Hello, hold on. Guys, listen. Shh. Class. Hey guys. It's not exactly the theorem, but listen. Hello. The theorem says, triangle proportionality theorem says A over B is equal to what? But could you multiply both sides by B and divide both sides by C and so forth to get A over C equals B over D and so? Yeah, you can work this out algebraically, can't you? Hello? Okay. What about the last one? This doesn't make any sense. A J to A C. Any question? Does this make sense? Yes? Alright. Let's look at the next example. Try this. Find X for this triangle. You should all be able to do this. By the way, what do you think this means? Right here, this has same symbol as this. Yeah, those two angles are? Okay, go ahead. Everybody try. I'll wait. Okay, so for example 3, do you think we could use this triangle angle bisector theorem? Yeah, because it's got the angle bisector. So what do you know about, this angle is being bisected, right? So what do you know about, what does it say? Triangle angle bisector theorem. It says, right, FG over G is equal to what? FD over DE, correct? So what is this? 12 over 24 is equal to what? 10 over?
X minus 10.
Yeah, x minus 10. You could write x minus. Or let's just call it y. Isn't that easier? Because if you know what y is, could you figure out what x is? Yeah. So if you call that y, what does y come out to? Y is equal to?
20.
Well, if y is 20, guys, what's x?
30.
Right? 20 plus 10. Easy enough?
Wow, that was easy.
Okay, this one was very straightforward.
Wait, but I didn't know it's similar. It's not. It's theorem.
Yeah, these. Oh, that's a good question, guys. Man, hello, guys. Pass. Can I have attention? Is the triangle on the left and the triangle on the right, are they similar? No, that's not why this works. Remember this theorem? Right? The triangles on the left and right are not similar triangles, but because these, that's what it says right here, right? The one small one and then this big one after you draw the auxiliary lines, they're similar, not these two. Okay, any question on example 3?
No.
Okay, let's go to example 4 then. All right, go ahead. Everybody trying to go ahead and find x. Everybody find x. I'll wait. You got. By the way, how many parallel lines do you have?
3.
Okay, and you got 2 transversals. What do you know about 3 parallel lines cut by 2, and you got 2 transversals? You should know something about. Yeah, you should know something about this. Go ahead, everybody try. I'll wait. Chris, what would you do on this one here?
Yeah.
Chris? Yeah. Is this a theorem or it was a corollary, wasn't it? Yeah. So tell me what to write. Yeah. Correct. You guys remember the corollary that came after the first theorem? So then how do you find x? Well, I don't want decimals. I like fractions. So x equals to, multiply both sides by 9. What's x equals to? Okay, that's good enough. Okay, there you go. Any questions? Okay, any question? Class, does this make sense?
Yes, sir.
Do you understand?
Yes.
Can you do something like this for your homework tonight, Jonathan? All right, here you go. Good.